Hello everyone, Ron Johnson here from L.T.L Tutoring Central. And if you're looking for tips and strategies to help with your learning, you are in the right place. Solving algebraic equations. Don't panic, don't leave. I promise it won't hurt. I'm going to provide you with 10 examples of how to solve basic algebraic equations by doing the opposite. And that sounds like a contradiction, but it will become clearer as we move through the examples. To solve an algebraic equation, you're generally trying to discover the value of the variable. The variable is a letter. It's often x, but it can be any letter, as you'll see when we move through the examples. And in an algebraic expression, the letter stands for any number, basically. But in an algebraic equation where we have one variable or one letter, we have enough information to solve, or in other words, to find the value of that letter. All of this will become more clear as we go through the examples. So let's get started at solving algebraic equations. Solving algebraic equations, do the opposite. Well, what do I mean by that? Well, we want to get the x, or the variable by itself, the letter. And in this very basic equation, we have 37 plus x equals 101. So in order to get the variable, or the letter x by itself, I need to do something with that 37. I need to get rid of it or reduce it to 1, so I have 1x on the left-hand side of the equal sign. Remember, an equation means equal. Both sides need to be equal. If we have an equal sign, whatever's on the left needs to be equal to what's on the right. You can think of a balance scale for that. So in order to eliminate the 37 on the left, I can just subtract it. It's a positive 37 now. So if I subtract 37 from 37, then I'm left with just x on the left. However, in order to keep the balance, I need to subtract 37 from the right side as well. So 101 minus 37 equals 64. And you can see there, x equals 64. So if we do the opposite operation, that's what I mean by do the opposite, we will end up with the correct answer in the end once we get the variable by itself. And so just think of it this way. If I add something on the left side of the balance scale, I need to add it on the right to keep it balanced. Or if I subtract something on one side of the equal sign, I need to subtract it on the other, again, to maintain that balance. Let's try a subtraction example. X minus 42 equals 1,214. Well, at the moment, I have minus 42, which is the same as negative 42 on the left, which I need to eliminate so that I have the variable, or x, by itself. So how do I do that? Well, I add 42 in the second row. You can see we've added 42 to both sides. Remember, we have to do the same thing on both sides. We add 42 because negative 42 plus 42 eliminates the 42 on the left side and leaves us with x by itself. You can see in the third row, 1,214 plus 42 equals 1,256. And so that is our answer. That's the value of the variable x in this equation. Now we flipped it around. We have negative 35 plus x equals 17. But this doesn't really change anything. We're still trying to get the variable by itself. And we have a negative 35. Well, similar to the previous slide, we add 35 to eliminate the 35 on the left-hand side. And because we add 35 on the left, we must add it on the right. Negative 35 plus x leaves us with x alone. And 17 plus 35 leaves us with 52. So the variable equals 52. Here we have a basic multiplication equation. 18 times s equals 414. Now remember, it doesn't always have to be x. In this case, the variable is represented by an s. I did that in part because when we use the times symbol, it looks, well, it is an x. So we'd have xx, or times times, so it would look very odd. In parentheses to the side, you see 18s equals 414. Multiplication is often written this way with a variable right beside the number. That just means the same thing as 18 times s, or 18 times the variable. Well, we do the opposite. 18 times s, we're going to divide by 18. And that will leave us with 1s, because 18 divided by 18 is 1, and 1 times s is s. We don't put the number 1 usually. In the third row, you'll see s equals 23. That's because 414 divided by 18 is 23. And we, just by convention, don't normally write 1s, but that's what it is. So don't let that confuse you. It's 1s or 1x. In the previous slides, we could have put that 1x beside the variable. So 18 divided by 18 leaves us with 1. 1 times s is s. 414 divided by 18 is 23. So the solution is s equals 23. Similarly with division, we have s divided by 48 equals 72. Well, the opposite or the inverse operation of division is multiplication. So I'm simply going to multiply both sides by 48 so that I'm left with just s on the left, and on the right I have 72 times 48 equals 3,456. So the variable s equals 3,456. So you see how easy it is? Just do the opposite. On the previous slides, you might have noticed they're quite basic equations, and you think, well, I can solve this without going through all those steps or any kind of procedure. They're easy enough to solve in other ways, and that's true. You can also often do it just with mental math or just by inspection. However, as the numbers become larger or the equations become longer, it's more and more difficult to simply do it by inspection. And so it's better to learn the procedure with some easy questions that you can very quickly check to ensure that they're working for you, and then you're prepared when you get to some longer or more difficult numbers. So here's one that's a little bit more challenging. 623 plus 2m minus 32 equals m plus 900 minus 18. But don't let that scare you off. It's still quite simple to do. First of all, look on the left and the right of the equal sign, the balance, and solve any math that can be done already. Now, we can't do anything with the 2m on the left at the moment, but we can subtract the 32 from the 623. And in the second row, you'll see that gives us 591 plus 2m. 2m hasn't changed, but 623 minus 32 is 591. On the right-hand side of the equal sign, we can't do anything with the m at the moment, but we can subtract 18 from 900, and that gives us 882. Now we can start moving things. So let's move the 591 from the left-hand side of the equal sign to the right. It's a positive 591, so that means I'm going to subtract it from both sides, and that leaves us on the left with 2m, and on the right it leaves us still with the m, but 882 minus 591 is 291. So in the fourth row, you'll see 2m equals m plus 291. Now I want to get that single m on the right over to the left. It's a positive m, so I'm going to subtract it from both sides. Remember, do the opposite. So I have now 2m minus m equals m minus m plus 291. And 2m minus one of those m's leaves us with m, or 1m, on the left. And on the right, we're simply left with 291. So the variable m equals 291. Now, as you become more proficient at doing these, you can do several steps at the same time. I have just shown every single step in a separate line to try to make it easier to understand how the procedure works. But it's basically do the opposite until you end up with the variable by itself. In this equation, we have negative 67b equals 36. You can look at this as a fraction or division. So negative 6 over 7, it's basically dividing, so we can multiply both sides by the denominator 7. And you'll end up with negative 6, 7b times 7 equals 36 times 7. So on the left-hand side, you'll have negative 6b equals 252. From there, we can solve by using division because we have a multiplication on the left, negative 6 times b. Remember, when the digit and the variable are together, that means multiplication. So we divide both sides by negative 6 in this case because I want a positive variable. So a negative 6 divided by a negative 6 gives me a positive 1. In other words, I'm left with 1b on the left, and 252 divided by negative 6 will give me a negative 42 because there's a positive divided by a negative. When the signs are different in division, you will have a negative answer. Let's look at a slightly longer algebraic equation similar to the previous slide. 2/3 y plus 1 equals 3. Well, I want to get rid of the whole number 1 first, and I'll leave the fraction for the next step. So 2/3 y plus 1 minus 1, remember I'm going to do the opposite and minus that 1 out of there, equals 3 minus 1. That leaves me with 2/3 y equals 2. Now I'm going to multiply, because remember 2/3 or 2 over 3 is like a division. So I'll multiply 3 on both sides, always multiply by the denominator. And that leaves me with 2/3 y times 3 equals 2 times 3. Or in other words, on the right-hand side of the blue line, you can see 2y on the left equals 6 on the right. Now 2 times y, we are going to divide. We're going to do the opposite. Divide both sides by 2. 2y divided by 2 leaves me with 1y, or just y. And 6 divided by 2 leaves me with 3. So the solution to this algebraic equation is y equals 3. Here's another example. 396 divided by r, or you can look at it as a fraction, it's the same thing, equals 22. So because it's division, I'm going to use multiplication. But remember, multiply by the denominator. So now it's 396 r times r equals 22 times r. Now this might be a little confusing at first because we flipped, and the r is now on the right-hand side. So we're left with just 396 on the left, and on the right side of the equal sign we have 22r. So we do the same thing though. We need to divide by 22 to leave the variable, or r, by itself, because right now it's 22 times r. So we divide both sides by 22, and we're left with 396 divided by 22 equals 22r divided by 22. And in the end, I have flipped it back to the convention of having the letter by itself. So we'll have r, or 1r, equals 18, because 396 divided by 22 is in fact 18. Here is a fraction or division again with the variable on the top and the number on the bottom. So p divided by 568 equals 994. Because it's division, I'm going to do the opposite. Remember, keep that in mind. We're going to multiply. So p divided by 568 times 568 equals 994 times 568. And therefore, p equals 564,592. Now, in all cases, it's a good idea to check your solution to ensure that it actually works. I'm not going to go through all of the equations that we did here, but you're certainly welcome to do so. Now, what you do is plug in your answer to the original equation, work it through to the end, and see if you end up with the correct result. So I'm going to look at the longest equation we did on our examples. And if you remember or look back, the answer was m equals 291. So the original equation was 623 plus 2m minus 32 equals m plus 900 minus 18. So we simply plug in or put in the number 291 wherever there is an m. So in the second row, you can see 623 plus 2 with 291 in brackets or parentheses. That just means multiply. So 2 times 291 minus 32 equals 291, because that's where that other m is, plus 900 minus 18. If we begin doing the math, and you could do this all at once, but I've shown a couple of steps. You'd have 623 plus 582, because that's 2 times 291, minus 32 on the left. On the right of the equal sign, you have 1,191 minus 18. If you do the math on both sides now, you end up with 1,173 on the left and 1,173 on the right. And remember, an equation has to be equal on both sides. So the fact that you got the same number on both sides proves that you have completed this equation correctly. Now, you might have lots of questions. Often when we're learning something new, or even reviewing something that we've done a long time ago, new questions pop up. So you might have questions about multiplying or dividing or handling fractions, using reciprocals, etc. Or why do we do certain operations? How does that get us where we want to go? How does that turn into a 1, for example? So if you have any questions, don't be afraid to ask. You can ask below if you're watching on YouTube. You can connect with me through my email. The email is on every slide, but I'll also put links below, and you can check out the website and get in touch with me in that way as well. So don't be afraid to do that. In the meantime, keep having fun, keep learning, and don't be afraid of algebraic equations. Just do the opposite. It's Ron Johnson from L.T.L Tutoring Central. Until next time, bye-bye for now.